Hi everyone, I'm Eugene Brits from Energy Insight. I'm representing Energy Insight and Energy Cybernetics for today's show and tell. I read a number of IoT kind of articles, and in many of the articles you'll find that many of the authors try to explain IoT in terms of your refrigerator at home having the capability, let's say for instance your milk is getting low, to automatically order new milk for you, or if your milk is getting aged, it will order milk for you and replace the old aged milk. So given that, I decided to select one of our customers in the financial services group, Standard Bank South Africa. We all know this one, load shedding is a problem, but for Standard Bank, energy security is a big issue. So in terms of energy security, it's not only Eskom load shedding that's a problem. Your municipal infrastructure that's aging is a problem. Theft, vandalization is a problem. It will leave them without power to their buildings. The other problem that one sits with is the supply of the electricity to the building. In other words, your voltage, your frequency. Is it within limits? Will it damage the UPS or other equipment? Okay, so how do we go about helping them with their energy security needs? So we've got smart devices that we can connect to the generators, the power supply, the UPSs. We can take all that data and via the GSM or GPRS network or some other network infrastructure, we can bring it back to service in the cloud. From the cloud, we've got the capability of then supplying that data to the users via the internet. Okay, so the question now comes in, how does this relate back to our scenario of the refrigerator ordering new milk? Well, it becomes very simple. If you take, for instance, we're monitoring the generators. We do know what the fuel levels of the generators are. So let's say there's a power failure. The fuel level falls below a certain threshold. It's simple. We traditionally would have sent an SMS to the facilities manager. The facility manager would pick up the phone, phone the supplier of the diesel and tell them, please come and deliver diesel. Well, what can we do now? We can directly send that SMS or email to the fuel supplier. The fuel supplier can acknowledge that they've received that SMS or request. Once they've acknowledged the request, the people on site or the security personnel knows that if a diesel delivery is coming within X amount of time, and the manager can sit at home whilst his energy security is in place and diesel gets delivered. Just maybe example of what had happened in Joburg this year. I don't know if you've read that the south of Joburg was without power due to cable theft for more than a week, I think about 9 days. So Standard Bank has a digital printing press in the south of Joburg that was running on diesel, and we at 28 times had to reorder diesel to keep that printing press running. Okay, so in terms of having backup energy, we can now suddenly do preventative maintenance alarms. For example, let's say the coolant in the generator becomes low. We can send the vendor and tell them, please come and fill up the coolant, or some other alarm is triggered. We can do reactive alarms. In other words, let's say the generator was running and suddenly it trips due to overheat. We immediately send an SMS to the vendor or email telling them, please come out. They acknowledge the SMS, they start to come out, and we reduce the turnaround time and thus increase the uptime of the generator system. In terms of once you start monitoring all of this, let's say I've got the fuel level and I know whether the generator is running or not, I can start to do intelligent calculations. Let's say my fuel level is dropping, but the generators aren't running. So either somebody's stealing fuel or I'm losing fuel due to leakage. And we had a typical example at 5 Simmons where one of the transfer pumps between the bulk tanks neglected to stop pumping, and it started to overflowing. So they overflowed by about 1,000 litres. If that wasn't detected early enough, we would have overflowed by about 50,000 litres. Okay, then in terms of power systems monitoring, where we look at the voltage frequency, Standard Bank started to notice that they had a bunch of startups of their rotary UPSs, and they couldn't figure out why. Everybody was blaming the power supply, the voltage was too low. But once we started doing a bit of analysis with the data that we got from these smart devices, we realized that the drops of the rotary UPSs were actually starting up due to the fact that we had high frequency problems in South Africa. So we were going above 50.2 Hertz, where the rotary UPS was programmed to start up at 50.2. They started to change that to 50.3. Now suddenly they reduced their fuel consumption or diesel consumption by 120,000 Rand a week. So that's just how you can use that smart devices to get over such problems. Typical products that we will typically use is Schneider connected products, so their ION range of products. Schneider power quality meters also falls in their ION range of products. We've import fuel probes from Russia, which has the capability of detecting water in your diesel. So that's a nice thing, a very accurate level sensor. Then we use TrueTech, local companies' SPRI routers to get the data back to our systems. We typically will use the Schneider Power Monitoring Expert for the power quality analysis. And then we've got EI Enterprise, our own software package that takes all this data, and we mine through the data, and we then do the analysis, and we then decide which one of the SMSs to send or whether to, take other actions or why stuff is happening. Okay, and this is maybe just a screen capture of what it looks like. This is, for instance, Standard Bank's headquarters in Malawi, where we do fuel monitoring, diesel generator monitoring, as well as UPS monitoring. So it just shows you with the communication capabilities we have today in the IoT infrastructure, the cell phone networks, it's possible to get data back to South Africa very simply, very easily. Okay, thank you.
Eugene, well done, thanks. So this would you suggest that this is more of a reactive solution? So it waits for an event to be triggered and then action is taken.
So in terms of a generator controller, for instance, it will be reactive and preventative. So let's say the generator is standing there, there's not a power failure, but your coolant, let's say the coolant in this inside of the system is starting to leak out. That's a preventative thing. It will not start when there's a power failure, but if you can fill up the coolant and repair the leak beforehand, you've actually got a preventative maintenance thing. So let's take, for instance, another example. You've got phase rotation. The generators are sensitive to phase rotation startup. So let's say the municipality does work on the electrical supply and they change the phase rotation. The generator will not start up because the phase rotation has changed. The controller can pick that up, and it's a preventative maintenance item that we can send. So there's about 10 or 15 preventative things that you can do, as well as obviously once the generator is running and it trips on over temperature, that's a reactive thing. You cannot detect it beforehand.
And in terms of gathering that information, is there ability to build a predictive analytics engine? So in other words, it says under current circumstances you're likely to have an outage in 2 days' time, or is
No, it's
that
that's your. I think that's going to be a very difficult one to predict, unless you've got an extreme amount of events which we currently do not have in South Africa. You cannot predict somebody vandalizing or stealing a cable. You cannot predict a substation blowing up. I think it's too random at this stage. My personal opinion. I'm not sure.
So maybe, Ian, I think a lot of the clients we found, first of all, don't do basic monitoring. So if they don't monitor or measure, we can't do anything with it. I think at a broader substation level, when we look at substation automation and control, and monitoring really transformers and the loading thereof, you can do a little bit of predictive stuff in there to say, fine, this substation, bay number 3, it's either overloading for X, Y, Z, and then you can look at downstream distribution and stuff like that. So you bring in some form of intelligence at the substation automation level, which can be then put into your national control room, etc. And it's the same for your call it the Eskom power station fleet. They have, on a central NOC, bring all the information in terms of which units are online, what they're doing, etc. When they're down, also from a maintenance perspective, how quickly that they can come up or not is all monitored centrally. So a lot of that at the utility level is happening. But I think in this case specifically within a Standard Bank and a bank being also very important in terms of backup power and the quality of power, you can't be affording to go down. These are some of the interventions they're put into play to bring the information as a visibility. I think the layer on top of it in terms of what you do with all this info now and make the right analytics work with it and making it more clever on a sort of a single platform is where the opportunity probably lives in terms of giving that to them. I mean, it's the same of the banking. The banks run analytics in terms of our spend, our usage, where we do is, using our credit cards and bring those type of intel to bring different apps to us to say, listen, there's a special here or there, or even for the retailers. I think that's the other layer that we can really bring this thing down. So from just bringing monitoring or devices to bring data into one place, this is one of the starts.